Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to calculate the delta S of a change in state. So delta S is the change in entropy. How do we calculate that for a change in state? So one of the equations you can use is this equation of Q, oops, delta S is equal to the heat of a reversible process over the temperature of that process is happening in. So we can use this. We need to make sure that temperature is in Kelvin as usual. And so let's go over an example. A couple of examples. The first one is you have 25.0 grams of water and it's condensing at 100 degrees Celsius. We can use this equation because one, we're at a temperature that's constant, and the temperature we're at is that of boiling. And so both condensation and vaporization is happening at this particular moment. So this is where the reversible process occurs. So we can use this. All we need to do is make sure that temperature is in Kelvin. So we'll have 100 degrees Celsius plus 273.15, and that's going to give us 373.15 Kelvin. And the next thing we need to do is we need to look up the vaporization of water, because we're going to need to know what the condensation to get our Q reversible. That's where the Q is. So since we're condensing water, it's going to be the opposite of vaporizing water. So if we look up the vaporization, the heat of vaporization is 40.7 kilojoules per mole. So the heat of vaporization is equal to 40.7 kilojoules per mole. Since the heat of vaporization and the heat of condensation or freezing are opposite to each other, then this is going to be equal to 40. The heat of condensation is equal to negative 40.7 kilojoules per mole. Okay, so now that we have our heat of vaporization, we're going to use this to find the Q, the heat. So we need to get rid of moles. So we just want joules. So what we're going to do is we're going to take the 25 grams. So we got 25.0 grams of water, H2O, over 1. We're going to multiply that by our molar mass. So that means that 18.016 grams of water on the bottom, and we have 1 mole of water on top. So grams is going to cancel out. Now we have moles. Now we can use this as a conversion factor to convert moles to kilojoules. So we have negative 40.7 kilojoules. So 40.7 kilojoules per mole of H2O. Moles of H2O cancel out. And now we have kilojoules, but we want to get rid of kilojoules. So one more. So we have 1 kilojoule on the bottom and 1,000 joules on top. So kilojoules cancels out. And then if we do that calculation and we get 5.647. So 5.647. So this is going to be 5.647 times 10 to the fourth joules. Okay. Sig figs. So we have 3 sig figs. 5 here, 3 here. So we should only have 3 there. Now that we have joules, we could plug in. This is our heat. This is our Q reversible process. So that means delta S is going to be equal to, which is equal to Q reversible over T. So then that's going to be 5.647 times 10 to the 4 joules over our temperature in Kelvin, 373.15 Kelvin. And then we calculate that out, and we get 151. So this is going to be 151 joules per Kelvin. So that is going to be the change, and this is this should be negative, right? I forgot the negative there, so that this should be negative. This should be negative, and so this is going to be negative. So this is a negative 151 joules per Kelvin. So that is the first problem. Okay, now for the second problem. So same thing. We got 10.0 grams of acetone. It's going to vaporize at 56.1 degrees Celsius. So we're going to be vaporizing. This is the boiling point of the normal boiling point of acetone. So we're at an equilibrium temperature. The temperature is not going to change. So we can again use this equation of the change in entropy is equal to the heat of the reversible reaction divided by the temperature in Kelvin. So we got to convert, we're going to have to convert this again to moles. First we need to find the heat of vaporization of acetone. Okay, so the heat of vaporization of acetone is equal to 29.1 kilojoules per mole. Okay, so that's the heat of vaporization. We're vaporizing, so we don't need to change this to the heat of condensation, so we're going to use this. So now we can use the grams. We could use this to convert to joules of heat. So starting with 10.0 grams of acetone, C3H6O, we're going to multiply that by its molar mass. We need to calculate that first. And we get 58.081 grams of C3H6O, and then 1 mole of C3H6O on top. Grams cancel out. Now we can use our moles to kilojoules. So that's going to be 1 mole of the C3H6O on the bottom and 29.1 kilojoules on top. So moles cancels out. Now we have kilojoules, and now we need to convert that to joules. So 1 kilojoule on the bottom, 1,000 kilojoules on top. Kilojoules cancel out. Oops, joules should be on top. And now all we need to do is calculate this, and we'll get our Q reversible. And we get 5.01 times 10 to the third. 5.01. We get 5.01 times 10 to the third joules. And so we need to convert this to Kelvin. So 56.1 plus 273.15 is going to give us 329.25. 329.25 Kelvin. So for delta S is equal to Q reversible over T. So then it's going to be 5.01 times 10 to the third joules divided by 329.25 Kelvin. And that's going to give us 15.2. So that's going to equal 15.2 joules per Kelvin. So that is the amount of entropy change during the vaporization of 10 grams of acetone. So I hope this is helpful. I hope you learned a lot. I hope you enjoy my videos. If you enjoy my videos, please like, share, subscribe, hit the notification bell, put a comment in the comment section. Thanks for joining me, and I'll see you next time.